In today's video, I will teach you how to solve linear equations. Before we dive into solving linear equations, we need to understand what an equation is. An equation is a mathematical statement that the values of two mathematical expressions are equal and usually separated by the equal sign. It is linear when its degree is 1. The following are examples of linear equations. The above equations are all linear and are equations of straight lines. Consider the equation 2x plus 7 is equal to 2. This equation has 3 terms, one variable x. Also, the number multiplying x is called the coefficient of x, which is 2. This is a simple linear equation with one unknown, since x is the only variable present in the equation. To solve linear equations, we look for the value of the variable such that the left-hand side of the equation will equal the right-hand side, making sure that we maintain balance in the equation by performing the same operation on both sides of the equal sign. Consider the set of scales below. If we add, subtract, multiply, or divide by the same quantity, we will maintain its balance. Let's say if you subtract 2 squares from both arms of the figure, its balance is still maintained. To solve for an unknown, we isolate the unknown by performing a reverse operation of how it was formed on both sides of the equation. Let's solve the following. Case 1. Simple equations. 13 plus 7x is equal to -1. To isolate the variable x, we perform these operations. First, we subtract 13 from both sides of the equation, and then we divide both sides of the equation by 7. Subtracting 13 from both sides, we get 13 plus 7x minus 13 is equal to -1 minus 13, which simplifies to 7x is equal to -14. Finally, dividing both sides by 7 gives x is equal to -2. We can always verify by substituting the solved value back into the equation. Doing so, we get, for the left-hand side, 13 plus 7 multiplied by -2, which simplifies to 13 minus 14, which is -1. Which is exactly equal to the right-hand side, -1. So the value of x is verified. Case 2. Equations with repeated unknowns. Let's solve for x in the equation. 6 plus 2x is equal to 15 minus x. Notice that the terms in x are repeated. We have x on either side of the equation. So first, we bring terms in x together by adding x to both sides. This is because adding x is the inverse of the operation -x, and we get 6 plus 2x plus x is equal to 15 minus x plus x. The terms in x cancels out from the right-hand side, and we are left with 6 plus 3x is equal to 15. Subtracting 6 from both sides, we get 3x is equal to 15 minus 6, which boils down to 3x is equal to 9. Finally, dividing both sides by 3, we arrive at x is equal to 3. We can verify this value by plugging it into the equation. We get 6 plus 2 into 3, which simplifies to 6 plus 6, which is 12. And for the right-hand side, we get 15 minus 3, which simplifies to, notice that the left-hand side is equal to the right-hand side. So this value of x is verified. Case 3. Equations involving fractions. Let's take this equation. How do we proceed to solve for x? First, we are going to proceed by cancelling out their denominators. We can do that by multiplying each term by the lowest common multiple of 4 and 3, which is 12. Multiplying by 12, we get x divided by 4 times 12 is equal to 4 times 12 minus x plus 2 divided by 3 times 12. Simplifying, we arrive at 3x is equal to 48 minus x plus 2, all that multiplied by 4. Multiplying out the brackets, we have 3x is equal to 48 minus 4x minus x. Now we can add plus 4x to both sides, since it's the inverse of the operation negative 4x, which then boils down to 3x plus 4x is equal to 40. Next, if we add the term on the left hand side, we obtain 7x is equal to 40. Finally, dividing each term by 7 gives x is equal to 40 divided by 7. This value of x can equally be verified by substituting it back into the given equation. Now, let us review your understanding with the following question. Solve for x in the following linear equations. You may want to pause the video and then come back when you are done. Solving it correctly will yield the following result. Thanks for watching and see you in the next video.